Okay, today we're going to start a bridge engineering unit, and we're going to be doing some bridge building on the computers, virtual bridge building, and then eventually we'll be doing some models and prototypes in the classroom. So today we're going to learn how to use the West Point Bridge Design software, and our project um, is going to put us in an imaginary position as the head of Champion Engineering. And Champion Engineering has been contacted by the city of Terre Haute, and they've decided that they need to replace an unsafe bridge that crosses the Wabash River that connects Terre Haute with Illinois. And they've also contacted uh, other engineering firms, and in order to get this bid, we're going to have to come up with the least expensive design and therefore come up with the most efficient way of building this bridge using the least amount of material, but still produce a good, strong, safe bridge. So the new bridge criteria are that it will be constructed from the abutments from the old structure, so that's something that we don't have to worry about. It should be able to carry 2 lanes of traffic, and it should be a through truss design to match a bridge that's just down the road, the Grant Road Bridge. Okay, to get started with West Point Bridge Design, you just double click the icon on your desktop. If you don't have that, you can just go down to your start menu, and in the search area there just type in West Point, and then you want the one not for older computers, but just the regular 2013 edition. And if you want, you can just drag that down to your taskbar and pin it there, and then you'll always have it. So we'll double click that. First thing that comes up is the design tip of the day. These design tips probably won't mean much to you until you've used the program a little bit. So for now you can close that, but maybe in the future you can go through and read those. They'll be quite helpful, I think. The first dialog box that comes up is just asking us if we want to load a prior to bridge design, if we want to create a new one. We want to create a new one right now, so we'll say OK. And then there's really nothing to do on this screen, so we just hit next. And then here it's asking us, are we participating in a local contest? And the answer for now is no. Next. Here it's asking us some information about the bridge, and we need to change the deck elevation for the Terre Haute project to 4 meters. And we'll just leave it standard abutments, no pier, no cable anchorages. Next. We'll leave these at the default for deck material and for loading. Next. And then we are going to use a template. Remember, we needed to use a Pratt through truss for this project, so we will select that template and say next. And then in the designed by box, please put your name, and that will identify your reports when you print them out and turn them in. And finish. So this is what our design interface looks like. And to get started, we're going to look at the template for the Pratt through truss, and what we need to do is put our joints in first by just clicking right on top of these circles that are already there. That's we're just using the template that they've provided. And now we're going to put the beams in, and all we do is actually draw from one joint to the next. Draw every single line that the template shows there. Okay, so while we were drawing those beams, we were using the default setting of carbon steel, solid bar as opposed to hollow tube, and then the size is indicated right here. You can make the bars bigger or smaller. Right now, the cost of our bridge, with all the materials and the cost of building it and manufacturing all the parts, comes to $267,984.03. And here's our list of materials. So what we're going to do now is test the bridge and just kind of get a starting point and see where we're at. And the way you do that is just by pressing this little button right here. And it's going to run a load test animation. So the bridge worked. I'm going to pause it right here. Now you notice that the members are lighting up with two different colors, blue and red. The members that are glowing blue, those members are in tension, or they're being pulled. The members that are red, that are glowing red, are in compression. They're being squeezed. The brighter the color, the closer they are to failing. What we need to do is look at the members that are not glowing very brightly at all and realize that those are over-engineered. We have more material there than we really need. Ideally, what we're going to have here is a bridge that's close to failing in all its members. Then we know that we have the least amount of material that we need to produce a safe bridge. Because if it passed this test, then it is indeed safe. So we have a bridge here that is way overbuilt because we have members here that aren't glowing any color. They're just white. And here we have pale blue. So we could decrease the strength of those members substantially. So let's go back to our drawing board by clicking up here. And let's select all these vertical members. And I hit the control button so I can select more than one. Boom, 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 boom. And let's just make those smaller. And let's keep track of our cost here, $267,900. And let's make those smaller. And then run the test again. Okay, we're starting to get a little bit of color in those two vertical members, but we can still, looks like we can reduce that a lot. So we'll just keep going. Go back to drawing board, and those same ones right there, they're still selected. We can probably just go back up here and either change it this way by making it smaller, 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 and then go back to the test, see what happens here. Okay, we've got failure. So that vertical member right there, it's lit up in red. These two right here are too weak. So let's select that one and that one and increase the size. So in any case, you can kind of see what we're doing to the cost here. We're getting the cost down while still having the bridge pass its test. Looks like that middle member is not being stressed at all. Let's select it next. Make it considerably smaller. So we're slowly reducing the cost. So that's kind of the procedure. If you look over here at the compression force strength and the tension force strength, the closer you get to 1.0 or 100%, the closer you are to failure. And so ideally you'd have these numbers, you know, if it was a perfect world, you'd have these at, you know, 0.9 or so. So I need you to keep optimizing, trying to get this cost down as low as possible. And once you get the sizes optimized, you can also now start experimenting with maybe having some of those compression members using a hollow tube. See if that reduces your cost. You can also look over here and maybe use some of these more expensive higher strength steels and see if, even though they're more expensive, if this higher strength allows you to use smaller size, which will ultimately reduce your cost. These are all things you can just do by trial and error through testing. Okay, so to get started, your teacher will pass out a West Point Bridge Design Challenge 1 project sheet, and I want you to put your name and date on there, follow the instructions, and then as soon as you get your first bridge built, I want you to record the cost of it. And then as we approach the end of the period, I want you to record the cost of your lowest successful bridge configuration, and then I also want you to print it out in West Point Bridge Design. Just go up here to File, Print, and then that comes out of the printer. You'll staple that to your project sheet and turn that into your teacher. Thank you and good luck.